My name is Dan Atchison, and I'm a research scientist at the Max Planck Institute for Psycholinguistics and the Donders Institute for Brain Cognition and Behavior in Nijmegen, the Netherlands. This video is about how to perform an fMRI scan. Before the scan actually begins, there are a number of important steps that must be taken. First, every research participant must sign a consent form. This consent form indicates, amongst other things, that the research participant has been fully informed as to the purpose of the study, that the researchers will keep the data anonymous, and importantly, that the participant may withdraw from the study at any point in time without any penalty. Participating in an MRI study involves being in the presence of very strong magnetic fields. As a result, it is critical to ensure participant safety by having them fill out an MRI screening form. This MRI screening form asks questions about things that might interact with the magnetic field, such as, do you have any metal objects in your body? Do you have an active implant, such as a pacemaker? Or is there a chance you might have metal fragments in your body? Each of these would be a contraindication to participating in the study, and as a result, people would be excluded. In addition, we ask questions like whether people are suffering from epilepsy, as having a seizure in the scanner could be quite dangerous for the participant, and whether they suffer from claustrophobia, as participating in a study involves sitting in a relatively small space, as you will see in just a moment. Before entering the room with the scanner, we first ensure that research participants have removed any metal that they might be wearing, that any electronics that they have been removed from their pockets, and importantly, because the magnetic field is so strong, that any credit cards or other magnetized cards have also been removed. In addition, the scanner is quite loud, so it's important that people wear ear protection while they're scanning in the form of earplugs. Researchers will administer an fMRI experiment from a control room that is independent from the MRI scanner itself. This control room includes, amongst other things, an MRI station where researchers would be interacting with the scanner and controlling it. Here there's also a speaker for speaking to the subject while the scan is going on, and importantly, buttons close by in case an emergency happens and the scanner needs to be stopped. The experiment itself is controlled usually in a data presentation and collection center. Here we have things such as a computer for delivering stimuli to the participant, an eye tracker for keeping track of where people are looking on the screen and to ensure that they don't fall asleep. And here, an EEG computer as well for doing simultaneous EEG and fMRI. All of the equipment for administering an experiment and recording data is usually placed on a control rack, and this includes things such as the computers that are actually delivering stimuli or recording eye movements, equipment for sending signals to and receiving signals from the scanner, in addition to audio and video equipment for sending sound or recording sound or sending video. Here you can see a picture of the scanner and some of the equipment that we'll use during the scan. Both of these pictures were taken well away from the scanner itself for two reasons. The magnetic field produced by the scanner is so strong that if I were to carry a camera close to it, there's a good chance it would wipe the memory clean from the camera. If I were to get even closer, it's quite possible that it would even pull the camera into the scanner, which wouldn't be safe. So on the left, you can see the scanner itself, and importantly for running a functional MRI study, there is a magnetically shielded and safe camera that will be projecting images to the subject. On the right is some of the equipment that we'll be using, including the head coil that sends radio frequency pulses and receives signal, a mirror that's going to be used to reflect the images that are being put from the projector to the subject, and then some padding here, and this serves two purposes. One is that it makes the subject more comfortable. The second is that it tries to put them in a position where they're less likely to move. In the following video, you'll see us putting a participant into the scanner. To begin with, the participant is already lying down on the bed, and you can see that there's a cushion underneath their legs, which is there to make sure that they stay comfortable. They'll be lying in the scanner for somewhere around an hour and a half. In their hand is a button box that they'll use to respond to the stimuli we present them. And here, one of the technicians is putting padding behind the participant's head to make sure that they can be comfortable. Over their head now is the radio frequency coil, which will be used to send signals and receive signals during the scan. And here we put some padding around the participant's head. This does two things. First, it makes sure that some of the extra noise is canceled out, and also that their head stays nice and still once they're inside of the radio frequency coil. Now, here we're going to be putting on the mirror, which will take the display from the projector and angle it down towards the participant's head. This is so that they can actually see the stimuli we're presenting to them. And in this study, we're actually going to be recording what the participant says, so we have a magnetically shielded microphone that allows us to do that. As you can see here, the participant is asking about the button box. Here, the technician is making sure that the participant has an emergency squeeze ball that they can squeeze in case they want to get out of the scanner. And here, they line up the participant by putting a marker right by the person's nose. And finally, they're going to actually put them inside the magnet. The last step is to put a couple of pads underneath the participant's arms, and again, this is to make sure that the participant stays comfortable, as they'll be lying there for about an hour and a half. And it also makes sure that they know where they are in the scanner so that they don't move too much. Performing an fMRI study involves running a sequence of scans that include getting a localizer scan to know where the participant's head is in the scanner, getting a high-resolution anatomical scan, which will be used for overlaying functional images onto each participant's brain, and then running a series of functional scans. On the right-hand side here, you can see the results of the localizer scan, which is a very fast way of just getting a coarse look at the person's anatomy. In this video, you'll see the high-resolution scan we took of this research participant. And what we're going to do is scroll through the brain going from left to right so you can see the high anatomical detail that you get from this sort of scan. Functional scans involve selecting a field of view, which is the parts of the brain that we're actually going to scan while people are performing the task and we're recording the functional images. What you're hearing now is the sound of this particular scan sequence, which is an echoplanar sequence. It's a fairly standard sequence used in fMRI. And we've chosen a TR, or time to repeat, of 2.3 seconds in this scan. What that means is that every 2.3 seconds we are acquiring a full scan of the brain. And as you look at the screen here, what you can see is a brief flash, and what that is indicating is the beginning of a TR. So every time the screen is flashing here, we are acquiring a scan from the entire brain. So what you're seeing now is a view of the workstation while a scan is in progress. On the far left-hand side, you can see the actual controller for the imager, and on the far right-hand side, you can see the rack we have set up, which has computers for presenting stimuli, sending pulses to the scanner, or receiving pulses from the scanner. And then just to the left of that is the presentation display of what the subject is seeing. After the final functional scan, the subject is removed from the scanner and then debriefed to let them know what the whole study is about. And that's it. That's how you perform an fMRI scan. Many thanks to Jolien ten Velden, Paul Gauman, and an anonymous research participant who helped in the making of this video. And finally, thanks goes to the Donders Institute for Brain Cognition and Behavior, where this footage was made.